Hello, and thank you for watching this virtual presentation. This video will cover the IME430 term project on Campus Market. It will discuss a variety of issues that we sought after to solve inside of Campus Market. My name is Jesse Ford, and the other presenters in this video include Reagan Burns, Kristen Limos, Cole Thomas, and Danielle Tran. Campus Market is Cal Poly's neighborhood corner market. It is centrally located and provides a range of both general and specialty groceries as well as a Starbucks. This dining hub is a prime location where students, faculty, and guests can grocery shop, pick up a hot meal, or just grab something on the go. As a result of this wide variety, Campus Market is often flooded with people grabbing anywhere from just a couple to a large number of items. This difference in item count seems to cause waiting times at the register to be quite long, but we do not entirely know that yet for sure. This project seeks to identify the primary reason for these long waiting times so that the necessary action can be taken.
Our group wants to improve the waiting time of customers at the register. The checkout process is too slow to accommodate all of the customers, leading to a bottleneck and long queues of customers waiting to pay. Longer queues lead to a lower customer satisfaction, as most patrons would like to get out as soon as possible, rather than wait in line. A major symptom is that customers complain that they wait too long in line until they reach the register.
At the end of our project, we want to be able to report the primary reason for the long waiting times at the register. We are going to do this by creating a cause and effect diagram to identify possible causes for long wait times, designing and filling out a data collection spreadsheet, utilizing the 80-20 rule to find out what 20% of causes are resulting in 80% of the waiting times, and developing a hypothesis, performing a hypothesis test, and making recommendations. The main stakeholders in our project are our professor, Cal Poly Campus Dining, and the employees, management, and customers of Campus Market. There are many possible causes of our above described problem that can be categorized as related to personnel, environment, process, or equipment. Under each category, we identified more precise potential causes for long waiting times at the Campus Market checkout registers. We decided to focus our data collection on number of registers in use, queue length, number of items, and type of payment.
In order to collect data, we focused on observing the waiting process that a typical customer goes through while waiting in line to purchase their food. Timing is important in recording data here because the bottleneck of the problem can only be identified by understanding what is causing the delay in each transaction. A spreadsheet was organized using macros in order to expedite the data collecting process and use as exact time metrics as possible. The steps in the data collecting process using the spreadsheet are listed here. In our Pareto analysis, we decided to focus on 3 causes: number of people in the queue, number of items bought, and transaction type. First, we isolated each transaction by the number of items, payment, and total time elapsed. From our data collection, we observed that the average time spent on the payment was different for each payment type. Specifically, using a credit card chip took 10 seconds, a polycard 6 seconds, and paying with cash took 7 seconds. The weighted average was then calculated and used for the Pareto analysis. For each type of transaction, the designated amount was subtracted from the overall time elapsed and is designated as scan time. This scan time was then divided by the number of items for that transaction and is known as scan time per item. The weighted average was then calculated and used for the Pareto analysis. For the number of people in the queue, the average total time that the user waited in line was divided by the average queue length. The 3 averages we calculated were then used in our Pareto analysis and are reflected in this table. From here, we observe that 64% of the cumulative wait time was due to the number of people in the queue. 89% of the cumulative wait time was due to the number of items bought and the number of people in the queue. From this analysis, we made the following 3 hypotheses. 1. At least one mean payment is different from the others. 2. The number of people in the queue affects wait time. And 3. The number of items in the queue affects wait time.
So, we performed a one-way ANOVA hypothesis test with a Tukey comparison on the collected data for payment times between payment type, queue length, and number of items per customer. A 95% confidence interval was used to determine whether or not there were any significant differences between the average payment times. Our null hypothesis is that the average payment time for using a polycard is equal to the average payment time for using cash on a card with a chip. The alternative hypothesis is that at least one average payment time is different. At a 5% confidence level, there is enough evidence to prove that there is a difference in the average payment time between paying with your polycard or paying with a chip. Polycard was significantly faster. Our null hypothesis is that the average payment time for queue lengths 1, 2, 3, 4, and 5 are all equal to each other. Our alternative hypothesis is that at least one average payment time for any queue length is different. At a 5% significance level, there is enough evidence to prove that there is a difference in the average payment time between a 1 and 5, 1 and 3, and 2 and 5 queue lengths. Our null hypothesis is that the average payment time for people purchasing 1 to 5 items is the same as the average payment time for people buying 6 to 10 items or 10 items or more. Our alternative hypothesis is that at least one of the average payment times for number of items is different. At a 5% significance level, there is enough evidence to prove that there is a difference in the average time between purchasing less than 5 items and more than 5 items.
From our first hypothesis test, we concluded that there was only a real significant difference in payment time when a customer used their polycard versus a chip. Since using a polycard was significantly faster than the processing time for a chip credit card, we recommend the Campus Market implements a polycard-only line in which the only payment accepted are polycards. From our second hypothesis test, queue length versus time, we observed that there was a significant difference between payment times when between queue lengths 1 versus 3, 1 versus 5, and 2 versus 5, we recommend that if there are any more than 3 people in a queue, that there be at least 2 registers open. From the item range versus time hypothesis test, we observed that there was a significant difference in payment times once a customer had more than 5 items in their basket. There was no significant difference in payment time between customers who had 6 to 10 items and a customer who had over 10 items. We recommend that Campus Market implement an express line for customers with 5 or less items.